Hello and welcome to Amit's Tech Sessions. My name is Amit and I'm a software architect. In this session, I'm going to cover an AWS service called Elastic Container Service or ECS, and we'll also do a demo. So let's start. What is Amazon ECS? Amazon ECS is an AWS native service and also a fully managed service. It provides capabilities of container management and orchestration. So this is pretty much similar to EKS or Kubernetes. However, it's an AWS native service. So if you want to avoid the complexity of Kubernetes and ecosystem around Kubernetes, then Amazon ECS is a great option for you. Amazon ECS is highly scalable and also provides a great performance for containerized applications. Since Amazon ECS is AWS native, fully managed container orchestration service, you do not need to install your own container orchestration tool on your own infrastructure. Amazon ECS is also deeply integrated with rest of AWS services such as CloudWatch, IAM, etc. Amazon ECS does run a container orchestration engine. So to do all of that, it needs a compute underneath. With ECS, you can use three types of compute options. The first one is EC2. So EC2 is an AWS service which allows us to create virtual machines in AWS cloud. So technically, you can use virtual machines as compute option with ECS. Second one is Fargate. Fargate is an AWS managed serverless compute service which is designed to avoid the heavy lifting of infrastructure or virtual machines. With Fargate, you do not need to worry about any infrastructure. The third one is on-premises servers. So you can use on-premises servers for compute option with ECS. However, in this session, we are not going to focus on premises. So let's understand a few basic concepts of ECS. In ECS, you have a container that runs as part of ECS task. As we know, container is a standard unit of software which has everything packaged together which is required for your application to run, such as code, dependencies, configurations, etc. A task in ECS is a standard unit which can run one or multiple containers inside that. Best practice to run one application container inside the task, or you can say one business container inside the task. However, you can also run sidecar containers along with your application or business container inside that task. There's another concept called service. So service is an abstraction on top of the task. So a service can contain one or more tasks, and then it also allows you a mechanism to make your application available for load balancer consumption. So let's walk through the application workflow around ECS. There are three actors in this workflow: platform administrator, platform user, and application user. So initially, platform administrator creates the ECS cluster. Then platform user creates a task definition file. The task definition file is a text file in JSON format that describes one or more containers up to a maximum of 10 that form your application. It can be thought of as a blueprint for your application. Then platform user creates the service or task using the task definition file. Task, as we discussed earlier, is the smallest unit in ECS, which is similar to the concept of pod in EKS. Amazon ECS allows you to run and maintain a specified number of instances of a task definition simultaneously. So this is called a service. Now we have a service inside the ECS, we have a task inside that service. So now the application user wants to access that application. So how do application user access that application? So user can access that application via application load balancer or ALB, and in turn that ALB will send the traffic to the ECS service, and then user will get the actual outcome of that application. So we'll see that in the demo as well. So let's go to the demo. So this is ECS console in AWS console. Here I'm going to create a cluster, and I'm going to provide a name to the cluster called dev cluster. By default, infrastructure option is AWS Fargate, so I'm going to leave that as it is. There are other options as well, EC2 instance and external instances. So we're going to create a cluster here. So cluster is just a logical unit here. So it doesn't take too much of time in creation. Now the cluster has been created successfully. So we are going to create a task definition. I already have one, but we are going to create a new one for the demo. So I'm going to demo that Nginx container. So I'm going to name this as Nginx task 2. Launch type we will leave at AWS Fargate. We'll leave the default CPU and memory options. You can change them as per the requirement. We will leave the task role and task execution role as it is. Here you need to provide the container details. So here I'm going to provide Nginx as a container name, and I'm providing a URI from public ECR repository for the Nginx image. Container port, leave with default 80, leave other options as default, resource allocation default. We don't need any environment variables for the demo, logging is default. Everything else, we are going to leave the default, and we're going to create this task definition. So this is a kind of blueprint for your application. Now, we are going to create a service in that cluster. So we're going back to the cluster and we're going to the services. So we are going to create a service here. So we will use the launch type compute option of Fargate. Leave the platform version as latest. Here we are selecting the task definition which we created. So Nginx task 2. There's only one revision, latest. So we'll leave that as default. We'll provide a service name, Nginx service. We'll leave desired task to 1. We'll leave other options as default. Networking as default. We need the load balancing here because we want our application user to access the application, right, as per our flow diagram. So we are going to create an application load balancer. We'll provide this load balancer a name, Nginx LB. We'll choose the container to load balance is 8080. We'll create a new listener on port 80 and protocol HTTP, and we're going to provide a target group name Nginx LB TG, and we're going to create this service now. Creation of service takes a few minutes. So for this demo, I'll cut this short to save some time. So now the service has been deployed successfully. So now we will click on this service and we are going to get the load balancer details. We'll copy the DNS name of the load balancer and we will run this DNS name in the browser. And it is not working. So the reason for it not working is because we have a security group attached to this load balancer. And this security group does not accept the traffic from my IP. So we are going to create a new security group and we'll attach that to the load balancer. So Nginx LBST, I'll put a description, allow access from my IP to Nginx load balancer. Leave the by default VPC. We'll add an inbound rule here on custom TCP, and source needs to be my IP, and we will choose the port 80 here because our load balancer listener is on 80, and that's it. So we will create this security group. Now we'll go back to the load balancer and we will attach this security group to this load balancer and the next load balancer. So now we are going to use this DNS name again, and we are going to execute this in the browser in the new tab. Now we can see the landing page of Nginx container. So that was all for this session. In upcoming sessions, I'll be talking about ECS observability and security, and I will also talk about the best practices to run containers on ECS. That's all. Thank you very much. If you would like to connect with me on LinkedIn, there is QR code up on the screen. If you would like to connect with me on Medium, there is QR code up on the screen. Thank you very much.